Hello everyone and welcome to the chapter number 35 of Blender Master Course Geometry Nodes Creating Rocks. In the previous 3 chapters of this course, we created the base of landscape, this simple fence with the wood texture, and even distributed this grass all over the base. And in this chapter, we'll be creating some rocks that we'll place on the base of the landscape, and we'll also be finalizing this scene. And with this, we'll be understanding all these topics in complete detail. Also, if you are new to this course, then do check out the previous 35 chapters from the link of the playlist in the pinned comment. So this is how our scene looks right now. We have this simple looking fence and this grass spread over the base of the landscape. Now to create the rocks, we'll first add a cube in our scene and then do the changes in the geometry nodes editor. So first let's go to the solid view, and to add the cube, press Shift plus A, go to mesh and select the cube. Let's move it in the Y direction by pressing G and Y, and let's place it over here. Now we have added this cube in our scene, and to convert this cube into a rock, we'll go to the geometry nodes editor, click on this new button, and now we'll be using the subdivision surface node. So to add the subdivision surface node, press Shift plus A, go to mesh, and in operations, select the subdivision surface. Let's place it over here, and now this subdivision surface is applied on the cube. If you remember, we studied about the subdivision surface modifier in this chapter of the course where we covered all the modifiers in detail. And this subdivision surface node works in exactly the same way as the subdivision surface modifier. Now the reason for adding this subdivision surface node is that we want to turn this cube into a rock, and to create a similar shape, this subdivision surface node will help us. Basically, this node subdivides the surface of your mesh and also smooths it out. Now to control the amount of subdivision and the smoothing of your mesh, you have the level option here. So if I increase it, the amount of subdivision will increase, and similarly the smoothing will also increase. So you can see here that if I change the level to a value of 0, we get the original cube. If I increase it to 1, the subdivision will slightly increase and it will look like this. But if I increase the level to 2, the subdivision increases even further and the smoothness also increases. And this is how the level parameter in the subdivision surface node works. Then the next option that you have is the edge crease, and if I increase it, it will basically crease the edges of your mesh object like this. So this option is used to control the creasing effect of the edges, and similarly the third option is the vertex crease, which controls the creasing effect of the vertices of the mesh. And so these are the three main options available in the subdivision surface node. Now to give this cube a rock-like shape, we'll be using the extrude mesh node. So press Shift plus A, go to mesh, and in operations, select the extrude mesh, and let's place it over here, and the extrusion is applied to all the faces of the cube. To view the cube properly, for now I'll change the level of subdivision surface back to 0, and here we can see that all the faces of the cube are now extruded. To extrude only some specific faces, we'll be using the compare node and the index node. For this, we'll go to the geometry nodes editor, press Shift plus A, go to utilities, and in math, select the compare node. Let's place it over here. Let's also add an index node, and then we'll understand the purpose of adding them. So press Shift plus A, go to geometry, and in read, select the index node. Let's place it over here. Now the purpose of adding this compare node is that we'll be changing its mode to equal, and then we'll connect it to the index node and the result to the extrude mesh. And with that setup, we'll be telling the extrude mesh node about the face to be extruded. For this, take the index socket and connect it over here, then take the result socket and connect it to the selection. And now you can see here that only one of the faces is extruded. And to be more specific, the face at the index value, which is equal to the value of B, which is 0, is extruded here. See, the compare node has the mode selected to equal, meaning that it will set the value of A and B equal. As a result, the input will be the face at the index value, because we have added this index node, equal to the value of B, which is 0, and then the result or the output will be the face at the index value of 0. Then it will get connected to the extrude mesh, and as a result, that particular face will get extruded. Also, if you want multiple faces to be extruded, then you can change the mode to less than or equal, and if I increase the value of B from 0 to 1, then two faces are extruded here. Let's also do one more thing. Right now the data type is selected to float, but as I already told you, the index values are always integers like 0, 1, 2, 3. So I'll change the data type to integer. Let's connect the index node again and change the value of B from 0 to 1. Now, since we have set the mode to less than or equal, it will basically apply the extrusion to all the faces whose index value is less than or equal to 1, or simply the faces with the index value of 0 and 1. As a result, two faces are extruded here. Now, in the extrude mesh node, you can see that you have some option of individual, and it is turned on by default. This option basically controls whether the faces of your object will be extruded individually or not. And if I turn it off, then the faces will no more be individually extruded, and this is how the shape of the extruded cube is looking right now. And now if I go to the subdivision surface again and increase the level back to a value of 2, this is how our rock is looking right now. It looks very simple because we have not applied any distortion or any texture to it. For this, we'll be using the Musgrave texture node. And as I previously told you in one of the chapters, that in the latest version of Blender, the Musgrave texture is replaced by the noise texture, so we'll be adding the noise texture. So press Shift plus A, go to texture and select the noise texture. Let's place it over here. And to convert this into the Musgrave texture, you simply have to turn off this normalize option. Now since we'll be creating the distortion effect on the vertices of this cube, so we'll also be adding the set position node. To add it here, press Shift plus A, go to geometry and in the right category, select the set position. Place it after the subdivision surface node, and to distort the vertices, we'll basically be adding this texture effect to the position of different vertices. For this I'll be adding the position node by pressing Shift plus A, and in geometry, go to the read category and select the position. Let's place it over here, and to add both of them, we'll be using the vector math node. So press Shift plus A, go to utilities and in vector, select the vector math. Let's place it over here, take this position socket and connect it to the vector, and take this factor socket and connect it to the second vector. Now this will add the noise texture and the changes that we do in it to the position of different vertices. And to connect this with the set position node, I'll take this vector socket and connect it to the offset. And now here we have a sharp pointing texture applied to this rock. To control this, simply go to the noise texture and change the scale value. If I change it to 0, you will notice that basically no distortion effect will be applied to this cube. And if I increase it slowly, you will begin to notice slight distortion effect applied to the different vertices of the mesh object. And at a scale value of somewhere close to 1, you will begin to notice a slight rock-like texture. And if you want to give it a more smooth look, you can go to the roughness value and change it to 0. And now this is how the basic structure of a rock is looking right now. Now to give it some material, we'll go to the shader editor and click on the new button. Let's also turn on the render preview mode, and now we'll be creating a basic shader for this rock object. For this we'll be adding the Warner texture in the shader editor. So press Shift plus A, go to texture and select the Warner texture. Let's place it here, and to add the texture coordinate and the mapping node, simply press Ctrl plus T. But as I have told you in the previous chapters, in order to use this shortcut, you must have the node wrangler add-on turned on. Now I'll take this object socket and connect it to the vector, and to view the texture over here, hold down Ctrl Shift and left click on the Warner texture. And this is how the basic Warner texture looks on our object. Now this Warner texture will create these spots on the surface of the rock, and to make it look better, we'll be distorting these spots with the use of a noise texture. So go to the shader editor, press Shift plus A, and in texture, select the noise texture. We'll place it just before the Warner texture, and now we get a texture like this, where the spots which were due to the Warner texture are now distorted due to the noise texture. Now if you want, you can try to change the values, like the detailing in the noise texture or the roughness from here, but right now the basic shader of the rock is ready. But if you wish, you can also create a realistic looking rock shader by following the steps that I'm gonna do right now. Making a realistic texture for this rock is completely optional for you, but if you want to understand the advanced level of shaders, then you can do that by understanding the creation of this rock texture. So to make it look realistic, I'll go to the shader editor, let's zoom out, place this principal BSTF away, and right now we have connected only this noise texture to the Warner texture to create this distortion effect on the spots of the texture. But now taking a step forward, I'll be combining two Warner textures together to create a much better shader. For this, I'll select the Warner texture, press Shift plus D to create a duplicate, and let's place it over here. Similarly, I'll select the noise texture also, press Shift plus D and drop it here. Just like the above noise texture, this one will also help to create a distortion effect on the spots created by the Warner texture. To combine both the textures, simply take the vector socket of the mapping node and connect it to the vector of the noise texture, then take this color socket and connect it to the vector of the Warner texture, and to get a combined output of both the textures, we'll be using the mix node. To add it here, press Shift plus A, go to converter and select the mix node. Let's place it over here and change the type of data from float to color. Now we'll connect the output of both the textures to the color A and B in the mix shader. For this, I will take this distance socket of the first one and connect it to the color A, then take this one and connect it to the color B. To view the result, hold down Ctrl Shift and left click on the mix shader. And here you can see that we get the same result as before, and that's because all the settings in the second Warner texture and the noise texture are the same as the first ones. To create some variations, go to the second Warner texture and change the feature output from here. If I change it to the second option, this is how the texture will look. Similarly, we'll be checking out all the other options to see which one looks the best. Let's select the third one, and this is how it looks. Then I'll go for the fourth option, which is the distance to edge, and this is the result. I think that right now it has a texture which looks slightly similar to a rock, but if you want, you can change the value of scaling in the noise texture to make it look different. So if I reduce the scaling, the texture will also slightly change, and similarly you can also try to change other values like the roughness in the noise texture or the detailing, but for now it looks perfect. And to give it some grey color, we'll be adding a color ramp. For this, let's first connect this principal BSTF to the material output, so I left click on it and place it over here. Now to give it some color, we'll be adding the color ramp. So press Shift plus A, go to converter and select the color ramp. Let's place it over here, and to get a proper color, we'll be changing the position of these pointers and their colors in the color ramp. So first I'll select the black pointer and try to move it, and this is how the texture is looking right now. Similarly, if I select the second pointer and try to move it, you can see how the color in the texture changes. And if I take this white pointer here, where previously the black one was placed, you can see that the basic color is now white and the color of the texture is the black color. And now I'll select the white pointer again and let's change its color to grey color with the help of this brightness slider. Let's also reduce the amount of black color by moving the second pointer, and here it looks perfect. So now we have a simple rock texture applied to this rock object. Now just like any other shader, to give this one a realistic 3D look, we'll be adding the bump node. So press Shift plus A, go to vector and select the bump node. Let's place it over here. Now take this normal socket and connect it to the normal of the principal BSDF, and to get the result of the textures as the input, I'll take this result socket in the mix shader and connect it to the height. And here you can see that the bump effect is applied, but its strength is too high, so I will reduce it from a value of 1 to something like 0.5, and this is how our rock is looking right now. I think that the material of the rock looks perfect, so I'll rename it from here. Let's type rock and press enter, and now this rock material is saved. Now moving ahead, we'll be creating some duplicates of this rock and do some variations in it. To do this, we'll be going to the geometry nodes editor and use a new node, which is the duplicate elements node. To add it here, press Shift plus A, go to geometry, and in operations, select duplicate elements. Place it after the set position, and we see some changes here. You can notice that the rock has disappeared and there are some points distributed all over the faces. That's because in the domain option here, point is selected. But to view the rock, I will have to change this from point to face, and here we have our cube again. Now to create the duplicates of this rock, you simply have to change the amount in the duplicate elements node. So if I increase it, you see that nothing happens. And that's because the duplicates of this rock have been created, but all of them are placed at the same position as the original rock. In order to move them at different locations, we have to use a set position node. For this, I'll go to the geometry nodes editor, take this set position node, and to create a duplicate of it, press Shift plus D and place it after the duplicate elements node. Now to change the position of the rocks, I'll take this duplicate index socket, which basically carries the index value of different duplicates of the rocks that are created. So if I connect it to the offset in the set position, then now we can partially see the duplicates of the rocks in our scene. And to move them in different positions, we have to use the math node. So press Shift plus A, go to utilities, and in the math, select the math node. Let's place it over here and change the operation from add to multiply. Now if I take the duplicate index and connect it to the value 1, and if I take the value socket of the multiply node and connect it to the offset, then now with the help of the second value, I can control the position of different rocks. So if I increase it, the position will change like this. But another problem here is that these rocks are moving diagonally, and that's because the multiply socket is connected to the offset, which is controlling the offset in all the three axes, the x-axis, the y-axis, and the z-axis. But to move it only in the y-axis, we have to use the combine xyz node. So press Shift plus A, go to utilities, and in vector, select the combine xyz. We'll place it over here. Now to control the y-axis, I'll take this value socket and connect it to the y socket in the combine xyz, then take this vector socket and connect it to the offset. And now with the help of this multiply value, I can control the position of these rocks in the y-axis. So let's keep it to something like -15 or maybe -12, so that all of them are visible here. And now let's revise what we did. We added this duplicate elements node to create multiple copies of this rock. Then to change their position, I first added this set position node, and to control the offset, or basically the change in position, we used the multiply node. But then we faced an issue that the rocks were moving diagonally, and to fix this, we added this combine xyz node to control the movement only in the y-axis. And also if you want to increase the number of these duplicates, you can go to the duplicate elements node and change the amount from here. So if I increase it to 4, then now we have 4 copies of the rocks in our scene. Now moving ahead, you can see here that all these rocks are having the same rotation, and that's because these 4 rocks are not different objects, but they are simply the duplicates of the main rock. To change the rotation of each one individually, I first need to convert them into different instances. To do this, we have the geometry to instance node. To add it here, press Shift plus A, go to geometry, and here you have the geometry to instance. Let's place it over here. Now to convert each this into a separate instance, I'll take this geometry to instance and place it before the duplicate elements. And now we have only one rock in our scene. And the reason for this is that in the duplicate elements node, you can see that the domain is selected to face. And in this list, you also have the option of instance. Since we have converted the rocks into different instances, as a result, we have to change the domain from face to instance. And now here we have the 4 rocks back in the scene. And now to rotate each one of these rocks individually, we'll be using the rotate instance node. To add it here, press Shift plus A, go to instances and select the rotate instances. We'll place it just before the output, and with the rotation values here, in the rotate instances, you can control the rotation of these different rocks. For example, if I go to the rotation in the x-axis and change it, then these rocks will begin to rotate in the x-axis like this. Similarly, if I go to the rotation in the y-axis and change it, they will begin to rotate in the y-axis like this. And similar is the case with the z-axis. But to give each one, a random rotation, we have to use the random value node. To add it here, press Shift plus A, go to utilities and select the random value. Let's place it over here, and by default, the data type in the random value node is selected to float. But here in this list, you can see that we have different options. Since we want to control the rotation, so I'll be selecting the vector and then take this value socket and connect it to the rotation. And now a random value is connected to the rotation of the rotate instances, and you can see that each of these rocks are now having a different rotation in the X, Y and Z axis. To control this rotation, go to the random value node and change the maximum values. If you want that these rocks should not rotate in the X and Y axis differently, then you can change the values in the X and Y axis to 0, and then they won't get any random value of rotation in the X and Y axis and will rotate only in the Z axis. To control the rotation in the Z axis, go to the maximum value in the Z, and if I increase it, the rotation of all the rocks will change. So let's keep it to a value of somewhere near 10, and this is how the rotation looks right now. All the 4 rocks are having different rotations in the Z axis. Now, just like this rotate instances node, you also have a scale instances node using which you can change the scaling of different rocks. To add it here, press Shift plus A, go to instances, and here you have the scale instances. Let's place it over here, and this scale instances is very similar to the rotate instances, and the only difference is that this one is used to control the scaling of the rocks. To scale them randomly, we'll be adding a random value node. So I'll select this one, press Shift plus D to create a duplicate and place it over here. Now take this value socket and connect it to the scale, and the rocks will disappear because the maximum scaling in the X and Y axis is set to 0. So I'll select both of them and change it to 1. Let's also change the scaling in the Z axis back to 1. Now to view the changes properly, I'll go back to the solid mode, and here you can see that all the 4 rocks are now having different scale values, and also this one is very small as compared to the others, and that's because the minimum scaling value is set to 0, which means that the scale instances node will provide random scaling values to all the 4 rocks, which will range from a value of 0 to 1 in all the 3 axes. But to give it a better scaling, I will select the minimum values and increase it slightly, like if I change it to 0.4, and also the maximum values if I change it to something like 0.6, then now all these rocks will have a random scale value which can be anything between 0.4 and 0.6. Now in order to get a proper scaling of these rocks, I will be placing them in the landscape that we created here. For this, we'll go to the top view by pressing 7 on the numpad, and here we have these rocks, and this is the plane. To move these rocks to the plane, press G and Y, and let's place them over here. Left click to finalize, and now here are the 4 rocks placed on the base of landscape. Now to view them properly, we'll go to the camera view by pressing 0 on the numpad, and here we have one of the rocks placed. Now to view all of them properly from the camera view, we have to do some changes. For this, I'll go to the top view, and we'll be bringing all of these rocks closer to each other so that they're properly visible from the camera view. To do this, we need to reduce the distance by going to the geometry nodes editor, and we'll be changing the multiply value here. So if I change it, you can see that the distance between these rocks will begin to change, and they are now closer to each other. Let's also rotate them by pressing R and rotating them like this. Press G to move them, and let's move it to somewhere near the middle of the base. And this is how the rocks are placed in our scene right now. If I change the angle and view below the plane, you can see here that some of the rocks are not properly placed. To fix this, press G and Z and move them upwards, but now the other ones have moved slightly more upwards. To fix this, we'll rotate them. So press R and X and rotate it like this, then press G and Z to move them downwards. And now if I go to the camera view by pressing 0 on the numpad, you can see that at least 3 of the rocks are visible in the scene. To get a proper view, I will zoom out in the camera view, and this is how our scene is looking right now. And here I feel that the size of these rocks is a bit too high, so I will go to the minimum values and reduce it to something like 0.25, and also the maximum values to something like 0.35 or 0.4. Let's move them downwards again by pressing G and Z, and let's place them here. Now the rocks are properly placed in our scene, and so we'll be moving ahead to fixing the fence in the scene. If I come out of the camera view by pressing 0 on the numpad, then you can see on the base of the landscape that the fence that we created is not properly visible. First of all, its size is very small, and also some part of the fence, like this one, is going below the base of the landscape. And to fix this, simply select the fence, tab into the edit mode, press A to select all, and we'll be deleting all of them and then create some new fence. So press X and select delete segments. To create new fence, go to the top view by pressing 7 on the numpad, and let's zoom out. Now to create the fence, we have to use the draw tool, which is here in the toolbar. So we have to select it, and to draw the curve, simply left click, and if I drag my cursor and then release it, you can see here that it has formed this fence in our scene. But now also you can observe that it's not completely perfect. The fence at this part is clearly visible, but the one on the left hand side is hidden below the plane. As a result, it's not visible. And to fix this problem, I'll again go to the top view by pressing 7 on the numpad. Let's zoom out and press press X to delete all. Select the delete segments. Now let's understand a very basic thing. The result that we want to achieve is that we'll draw the fence and it should appear on the surface of the plane. But instead of that, whenever we are drawing on the plane, it does not take the surface into consideration. For this, press N, and here in the tool category, you have this option of depth. It is by default selected to cursor, and that's why we were facing this problem. But if I change it to surface, and now whenever I draw the fence, it will basically lie on the surface. To check this, left click and drag your cursor like this, and a fence is drawn here. And if I change the angle to view it, let's also zoom in, and here you can see that this fence is now taking the surface into consideration, and it is also bending according to the surface of the plane. And this is the use of the surface depth option here. However, if you look closely at some parts, you will notice that it's still not perfect. Here on the left hand side, the entire fence is visible, but at this part you can see that it's again falling below the plane, and that's because we have not applied much subdivision to this plane. And to fix this issue, go to the tool properties here, and here you have an option of tolerance. And to fix the problem of aligning the fence to the surface, you basically have to reduce the tolerance to a very low value. So I will reduce it to something like 1 or 2. Let's go to the top view again, press X to delete all, and select delete segments. And now if I again draw the curve, or basically the fence, by left clicking and dragging like this, and if I change the angle, let's also zoom in to get a better view. And here you can see that this time the entire part of the fence is lying above the surface of the base. Now even though it's properly aligned with the surface of the landscape, at some areas you will notice that the fence is not properly positioned. Like here you can see that the fence appears like this, and that's because along with considering the plane, it's also considering the grass, and that's why when I tried to make a fence over it, the fence got placed like this. And to fix this issue, we again have to delete the entire fence by pressing X and selecting delete segments. And before drawing the fence again, I will remove this grass temporarily from the scene. To do this, come out of the edit mode, select this plane, and here in the geometry nodes editor, if I break the connection between the collection info node and the instance to remove the grass temporarily, then now we have no grass in the scene, and so we can easily place our fence. And now to create the fence, go to the top view again by pressing 7 on the numpad, select the Bezier curve from the scene collection, tab into the edit mode, and now we can draw the fence. So simply left click and drag your cursor like this, and now let's view the fence by zooming in, and this is how our fence looks right now. Let's also go to the camera view by pressing 0 on the numpad. Let's also turn off the draw tool, and here the camera to view option is enabled, so if I will zoom in or zoom out, the camera view will also change accordingly. And you can see here that we now have these rocks in the scene and also this fence that we created, and it might be possible that you want to increase the height of this fence so that it is properly visible from the camera view in your scene. And to do this, simply go to the geometry nodes editor, then in the scale value here, we'll increase all the three to something like 0.25, and now here we have the fence scaled up in the scene. And if you want to increase the distance between the two fence parts, for this you can go to the resample curve, and if I increase the length, you will notice that the distance between the two parts of the fence will increase. Let's keep it to somewhere near 0.25 or 0.3, and here it looks perfect. And now to view the grass here, come out of the edit mode, select the plane, and connect the collection info node to the instance on points. And so here we have the grass that we created back in our scene. To view them properly, let's fix the camera view, so I will adjust it properly to get a better view of the scene. And here it looks perfect, so I will finalize this, and this is how the scene looks right now. Let's also turn off the lock camera to view, so that if I adjust the view, the camera view does not change. For this you can either click on the lock button, or you can press N, and in the view option, here you have the lock camera to view. Now moving ahead, you can see that the rocks that we have placed here are not shaded smooth, and to make them smooth, I will select them, and here in the geometry nodes editor, just before the output, we'll be adding the set shade smooth. So press Shift plus A, go to mesh, and in the right category, select the set shade smooth. Let's place it over here, and now we have made the rock smooth. Now let's come out of the camera view by pressing 0 on the numpad, and here you can see that some part of the fence is getting out of the plane. And to fix this, simply select the fence, tab into the edit mode, and we'll be selecting all these segments that are placed outside the plane. For this, simply left click and drag your cursor like this, and here some of them are left out, and to select them together with the others, simply hold on the shift button, and then I can select the remaining ones. Let's also select this one. Now to delete them, press X and select delete segments, and here the fence is now fixed. Let's also go to the other part of the plane, and here also you can see that some part of the fence is lying outside the plane. To fix this, let's zoom in, and we'll select these segments and delete them. So left click and drag your cursor like this, press X and select delete segments, and now we have deleted that part of the fence. And with this, our scene is also almost ready. To finalize it, let's first come out of the edit mode and go to the camera view by pressing 0 on the numpad. Let's also turn on the render view to see how the scene looks. And here you can see that we have each and everything properly placed in the scene, but still there are a few things which we need to do in order to finalize this scene. For example, the bigger part of the fence that we use for the texture has to be hidden while rendering, so I will select it, and in the scene collection, click on this camera icon. Now this cross on the camera will appear, meaning that this object won't be shown in the final render. And if you don't want to see it even in the viewport, then you can click on this I button. Now each and everything looks perfect except for the ground or the base of the landscape. In order to give it some material, I will select it, and if you remember, we created a simple sand shader in this chapter of the course. So we'll be using that shader to give some material to this ground. For this, I'll change this shader editor in the asset browser by clicking on this icon and selecting the asset browser. We learned about the creation of different shaders or materials and also about saving them in your own library in these chapters of the course. So if you haven't watched them, you can check the link in the pinned comment. Now to view only those materials that we ourselves created, click on this drop down menu and select user library. And here you can see that this is a sand shader that we created. So I will select it and drop it on the plane. And now we have the sand shader applied to the base of the landscape. However, one thing to notice is that the shader that we have applied is actually a sand shader and not a soil shader. And as we all know that since we have added a lot of grass in the scene, the base should have soil instead of sand. To fix this, we'll go to the shader editor and change its color. So click on this icon and open the shader editor. And here you can see that in the mix node, we combine these two colors to form the color of the sand. Let's also do one more thing. I'll duplicate this material so that whatever changes we make can be saved as a separate shader. For this, go to the duplicate button, and if you want to scroll like this, simply hold down the middle mouse button and drag your cursor like this. And here we have the duplicate material button. So I will click on it, and let's change the name of this material to soil. Now to make it look like real soil, I'll go to the color A and we'll change it to brown color. For this, let's reduce the brightness with the help of this brightness slider and change it to brown color. Now the reason why it appears purple is that in the color B we have applied the purple color. So let's click on it and let's change it to red color, or maybe a mix of orange and red. And this is how the soil looks right now. You can combine different colors together if you want to change the color of your soil. And also, if I zoom in, you can see here that it actually looks like real soil. The material is properly applied with a perfect texture, and with this our scene is almost perfectly ready. If you want to make it look different, you can increase the grass in your scene. For this, select the plane, go to the geometry nodes editor, and here you have the density option in the distribute points on faces. So if I slightly increase it, the density of the grass will increase like this. And here I think that it looks perfect, so we'll finally render it. In order to render this image, click on the render button and select render image. And here the image is finally rendered. It will take an average time of somewhere near 5 to 10 seconds to render based on your PC specifications. And you can check that time from here. For me, it took somewhere near 9 or 10 seconds and generated this output. And one thing to note here is that we are using the Eevee render engine, and that's why it's so fast. But if I close this and change the render engine from Eevee to cycles and then go to the render option and select render image, then now it will take much more time to render. But for now, we'll keep it to Eevee only. So I will close it and change the render engine back to Eevee. And yes, if you want to improve the quality of your render, you can change the sampling in the render. By default, it is set to 64, which is usually perfect for rendering in Eevee. But if you want, you can increase this value to get better results, but with more rendering time. For now, I will keep it to 64 and go to the render option and click on render image. So we have rendered the image, and if you want to save it, click on the image button, and here you have the option of saving it. And yes, this brings us to the end of this chapter. From the next chapter, we'll begin with understanding some new geometry nodes, and by using them, we'll be creating this house in Blender. So our next chapter will be the chapter number 36, geometry nodes creating a house. So don't forget to subscribe to our channel, press that notification bell so that you can get timely updates about the upcoming chapters. Thank you for watching, and we'll see you in the next one.